All right, in this study, we'll be treating exponential equations involving simultaneous equation. Okay, here, this is also part of indices, but in this problem, in this tutorial, we'll be treating the one that ends up with simultaneous equation, whereby the two variables are expected to be found at the same time from two equations. All right, now looking at this as the first example, we have if 8 raised to the power 8x, if 8 raised to the power x over 16 raised to the power x plus 2y is equals to 4, and x plus 4y equals 0, find the value of x and y. Now, in this question, we have this the first equation, this is the second equation, and we have x, we have y, we have x, we have y. Okay, in this kind of question, it is leading to simultaneous equation. All right, so we put that, having put it in mind, what we have now is we consider the first equation. Of course, all this equation has to be in linear form before we can be able to treat them. Okay, so considering this first equation, we have 8 raised to the power x over 16 raised to the power x plus 2y equals to 4. Now, in this kind of thing, where we have a fraction, like in our previous studies, you can go back to that study and learn how we dealt with this kind of problem. So here we say when we have a fraction, we'll cross multiply. Okay, so this is empty with over 1. We cross multiply, this one multiply this one multiply this. So what we have now is this times this and this times this. So 8 raised to the power s times 1 is equal to 8 raised to the power s equals to 4 times this equals to 4 times this. Okay, all right. So now we have, having gotten this in linear form, what our target now is to make the bases the same so that we can work on the powers. Now, making the base the same, the common base for all these things should be 2. If you should choose 4, 4 will not go because 4 raised to the power, this is 4 raised to the power 1. 4 raised to the power 2 will become 16, which is greater than this 8. So we choose 2. So we have 2 raised to the power 3 is 8, 2 raised to the power 2 is 4, 2 raised to the power 4 is 16. Okay, now we have the already existing power will now multiply this new 4. Okay, so we now have, looking at this, we have single time here, but what we have here is more than one time. This is 1 and 2. Okay, so because of these two, what we have to do is to apply the multiplication law, which is changing us to power of plus. Okay, so we take one of the bases and then add up the powers. Because of multiplication, we add up the powers 2 plus this other one, which is 4 times s is equal to 4s. 4 times 2y is equals to 8y. Okay, now at this point, since we now have single terms on both sides, what we have to do is to cancel out the bases. Okay, here is it. We cancel out the bases. Okay, so we now have 3x equals to 2 plus 4s plus 8y, which is this into the power. We equate the powers. Okay, now at this point we have to collect like terms. We have 3x, 4s crossing becomes minus 4s. Okay, everyone that has to do with variable comes over here, where the constant sits on the other side of the equation. So another variable, this is s variable. These are the s variables. The other variable is y. Coming over becomes, since it's plus here, when it crosses equality sign, it becomes minus 8y equals to 2 is already here. It didn't cross any equality sign, so the sign still remains the same, which is plus 2. Okay, so at this point, what we have is 3x minus 4x equals to minus s. You have 3, you bought 4, you'll be owing 1. That's minus owing. Okay, now a minus 8y equals to this 2. And this is the equation 1. Okay, so the reason why we stop at this point calling it equation 1 because this is just the format for the linear equation, which is there's nothing more to work on this place except we have another equation to work with it. So at this point, what we have to do is before this substituting. Okay. All right. Yes, we now solve equation 1 and 2 because the reason is because the equation 2 is already in linear equation. So we solve equation 1, this is equation 1, and equation 2 simultaneously, okay, by adding. Why are we adding? Look at this. It says plus and minus is equal to plus. So when you are looking for, we are using elimination method here, which I will teach you also which is also in another video under linear equations. Okay, so here we have plus, we want to eliminate s. This is minus s and this one is plus s. So since it's minus and plus, since the signs are different, we add up, okay? We add up the two equations. So we now have minus s plus s is gone, okay? Now, we now have minus 8y plus is plus. Minus 8y plus 8y is equal, you're owing 8, you got 4. When you pay the 4, you'll be owing 4. Okay, that's minus 4y equals to 2 plus 0 is equals to 2. So at this point, we need to make y subject the formula by dividing both sides by the quotient of this y, which is minus 4. Okay, all over minus 4. So minus will cancel minus, 4 will cancel 4. Okay, then we now have 2 over minus 4 equals to 2 here is 1, 2 here is 2. Okay, there's a mistake here. There's a mistake here. Okay, this is 1 over 2. Okay, so what we have as this answer here is 1 over 2. Okay, and of course there's minus in it. Okay, so it's having minus. Okay, this minus is empty with keeping the minus up. All right, so y is equals to minus 1 over 2. Now, substituting minus 1 over 2 for y in equation 2. Okay, now either you since you are using the elimination method, whether you substitute to equation 1 or equation 2, whether equation 1 or equation 2, you get the same value for x. Okay, now since we got minus 1 over 2, substitute for y in equation 2, we choose equation 2. Okay, we now say this is equation 2, s plus 4y equals to 0. Okay, so we now have, anywhere we say y, we'll put minus 1 over 2. Okay, so we now have s plus 4. 4y means 4 times y, which is times minus 1 over 2, which is the value for y, equals to 0. So at this point, having done that, this can cancel and give us 2, and this cancel will give us 1. So 2 times minus 1 is equals to minus 2. So we now have plus 2 times minus 2 times plus 2 times minus 1 is equals to minus 2. So we need to collect like terms. X is here equals to, of course, this is 0, nothing. Minus 2 crossing becomes plus 2. So s is equals to 2, where y is equals to minus 1 over 2. Okay, so at this point, the next question is question number 2, which is if 2 raised to the power 2a minus b is equals to 1 and 81 raised to the power a all over 9 equals to 27 raised to the power 3a minus b, find 2a minus 3b. This is what we are targeting to find. Now, in this case, we still consider the first equation, which is this. Considering the first equation, which is this. Okay, so at this point, of course, this indices equated to 1. Since it's equated to 1, our target is to make the base the same so that we can equate power. Now, we look for a base that will be raised to power something to give us 1. And that base, of course, we know that there's this 0 index law, which is anything raised to power 0 is equals to 1. Of course, since this is 2, we also take 2 here, raised to power 0, which is empty with 1. Okay, now at this point, since the bases are the same, we cancel out the bases and then equate the powers. So we now have 2a minus b equals to 0, and that is now linear equation. We now call this one first equation 1. Okay, so now we now consider the second equation, which is 81 raised to the power a all over 9 equals to 27 raised to the power 3a minus b, which is this one. Okay, all right. So having that in mind, since this is a fraction like we have been treating, since this is a fraction, this will multiply. We'll use cross multiplying method. Okay, this will multiply this will multiply this. So 81a raised to the power 81 raised to the power a times 1 is equal to 81 raised to the power a equals to 27 raised to the power 3a minus b. Okay, which is this, then times 9. Okay, this will multiply this. Okay, we are cross multiplying. Okay, all right. So this 9 is multiplying this. All right. So we now have, since it's now plain number, what we have to do is check out a way we can make the base the same. Of course, the common base for all of them is 3. So since the common base is 3, 3 raised to the power 4 will give us 81, and 3 raised to the power 3 will give us 27. 3 raised to the power 2 will give us 9. At this point, we now have 3 raised to the power 4a equals to, we open this bracket, 3 times 3a is equals to 9a, and 3 times minus b is equal to minus 3b times 3 raised to the power 2, okay, which is this. So at this point that we don't have anything to do with the power now, we look for a way to cancel out the bases. But before you cancel out the bases, we must have single term on both sides. This one is having 2, okay? So since there are 2, we take one of the bases and apply the law here. The law here, this is multiplication. So since it's multiplication, the law says we should add up. So which is this 2, this plus now, okay? We add up the powers, taking one of the bases, okay? So we now, since the bases are the same and single on both sides, we now cancel out the bases and equate the power. So we now have 4a equals to 9a minus 3b plus 2, which is 4a minus, of course, we want to collect log terms now. Every variable comes over here, constants the other side. Now 4a minus 9a crossing becomes minus 9a. Now minus 3b crossing becomes plus 3b equals to 2 is already here, which is 2. Okay, so we now have 4a minus 9a is equals to minus 5a. You have 4, you bought 9. You'll be owing 5 if you pay the 4 you have. So we now have plus 3b equals to 2, which is equation 2. This is not a linear equation. Okay, now taking these two linear equations, solving them, okay, we now solve equation 1 and equation 2. All right, now again at this point, before we'll be able to eliminate, I'm using the elimination method again. Before I will be able to eliminate, my target is to eliminate b, because b this one doesn't have any value here, so it will be easier for me. But in a, this one has, this one has. So what you have to do is try to make this one to have the same coefficient with this one. This is 3b, and this one is just 1 minus 1. So what you have to do is to multiply everything here by this 3, okay, which is equation 1 times 3. We now say equation 1 times 3, okay? Multiply everything here by 3. That is 3 times everything here. Now 3 times 2a is equal to 6a. 3 times minus b is equal to minus 3b. 3 times 0 is equal to 0. That's equation 3 now. Now that I've succeeded in that, I'll now ignore this equation 1 and then choose this equation 2 and 3, since they are not the one having the same coefficient of 3, 3. Okay, now I've taken the two of them. I'm adding. The reason why I'm adding is because if you look at this, both this this one, the b, which is my target, is having plus, and the next is having minus. So since the sign is different, I'll be adding. If the sign are the same, I will subtract, whether plus plus or minus minus. Okay, but this one is different, so I will add. So we now have adding equation 1 and 2. Now 6a minus plus minus is minus. 6a minus 5a is equals to 1a. Okay, now minus 3b will cancel plus 3b. Okay, now 0 plus 2 is equals to 2. So a is equals to 2. In other words, we've gotten, we now substitute the value, we now substitute these two for a in equation 1. I can choose any equation, whether 1, 2, 3. I'll still get the same answer. But it's better you choose the one that will be simpler for you. But every one of them will get the same answer for b. All right, so we now have 2a minus b equal to 0, which is the equation 1. Okay, this is the equation 1. So we now have 2 brackets. Anywhere we see a, 2. Okay, we now put 2 because a is equal to 2. Minus b equals to 0. 2 times 2 is equals to 4. Minus b equals to 0. Okay, so we now have to collect last times. Minus b is over here, equals to 4. Crossing becomes minus 4. Now b is equals to 4. How do we mean? You need to do something to remove all this minus here. Now removing the minus, we multiply everything here by minus, which is minus times minus b is equals to plus b. Minus times minus 4 is equals to minus times minus 4 is equals to plus 4. Okay, the reason why we do it is because we want b to be left alone, not minus b is not what we're looking for. We're looking for just b. Now that we've succeeded, the value for a is 2 and the value for b is equals to 4. So, but then this is not where the question ends, like unlike the first question we treated. Here we are meant to find 2a minus 3b, which is then solving for 2a minus 3b. We have, inside where we have a, we put 2, where we have b, we put 4, okay, which is this value we have here. Now 2 times 2 is 4, minus 3, of course, this the this 3 here, 2 here is this one, 3 here is this one. Now b is now 4. So 3 times 4 is equals to 12. 4 minus 12 is equals to minus 8. Okay, that's it for that very one. So the next question we treat here is, if 2 raised to the power x, 2 raised to the power 2s minus 1, and 2 raised to the power 2s minus 1, 2 raised to the power x minus y minus 2 equals to 2 raised to the power x plus 2 raised to the power y. 2 raised to the power 2s minus 1, 2 raised to the power s minus y minus 2 equals to 2 raised to the power s plus 2y 2 raised to the power 4. And the next equation is 2 raised to the power s plus 2, 2 raised to the power 3y plus 1 equals to 2 raised to the power minus 1. Find y and s and y. Okay. Now we still consider the first equation, which is considering the first equation, which is this. Now at this point, what we have here is the same thing as this. There's invisible times here. Okay. There's also invisible times here. This is sent with this 10 times this. Okay. Just like we have x, y. This is sent with x times y. So we can that means we are qualified to apply multiplication law here. Now apply multiplication law, it implies that considering this, we have 2. Now this is the question. This is still the first equation. We now have to apply the law. Instead of, we now take one of the bases, which is these two. Take one of the bases, which is one of the two. We now add up the powers, which is 2s minus 1, 2s minus 1. Instead of this times here, invisible times here, we put plus. We now have x minus y minus 2. We now add up the powers. Now the same thing apply here. This is the 2 base. We now take one of the bases, and instead of this invisible times, we now put this plus. Okay. So we now have, since the bases are the same at this point, we can now cancel out the bases and equate the powers. So we now have 2x minus 1 plus x minus y equals to, minus 2 equals to x plus 2y plus 4, which is this thing and this one, okay? And then at this point, we have to collect like terms. We now have 2x, which is 2s, plus s. Every variable comes over. Then s have not finished it. We have another s here. S crossing becomes minus s. Then we are through with s. Y, the first y here is minus y. Okay, the next is over the other side of the equation. 2y crossing becomes minus 2y. Equals to 4 is already here. Minus 1 crossing becomes plus 1. Minus 2 crossing becomes plus 2. So what we have now is plus s will cancel minus s. So we have 2s left here. And then what we have now is minus y minus 2y is equals to minus 3y. Okay, you owe 1y, you owe 2, another 2, you'll be owing 3. That's minus 3y. Equals to 4 plus 1 plus 2 is equals to 7. So which is now equation 1, because this now is plain says linear equation. Now considering the second equation, we have 2 raised to the power s plus 2 and then 2 raised to the power 3y plus 1 equals 2 raised to the power minus 1. Okay, this is minus 1. Okay, so this is the second equation. All right, so we now say, of course, the same thing is applicable here. There's invisible times here. We now, this is the times I brought it up here. So at this point, what I have to do is 2 raised to the power x plus 2 times, we put in the times, and then everything is just the same here. And then instead of these times, I now put plus and take one of the bases. Okay, I now apply the multiplication law. Then we now have equals to 2 raised to the power minus 1. Okay, we add up the powers here, okay, because of the plus and times law. Okay, we now have, having at this point single term on both sides, we cancel the bases. So what we have now is x plus 2 plus 3y, which is the basis, equals to minus 1 plus 1 first. Okay, now we now have to collect like times. X is here, 3y is here, equals to minus 1, 2 crossing becomes minus 2, 1 crossing becomes minus 1. Now we have x plus 3y equals to minus 1 minus 2 minus 1 is equals to minus 4. You owe 1, you owe 2, you owe 1, again you'll be owing 4. Okay, that's equation 2. Now that we have succeeded in getting the equation 1 and equation 2, we now solve the two equations simultaneously. And we add this time as well. The reason why we add straight is because the first equation, we have minus 3y here and plus 3y. So it's having 3 for y. So that means we can, and it's having minus and plus. Since the sign are different, we add, okay, the two equations. Okay, now we now have, these are the two equations we add up. Okay, 2s plus s is equals to 3s. Okay, this is 3, okay. All right, so we now have, this one will cancel minus x, will cancel 3x. Sorry, minus y will cancel plus y. And then we now have 7 minus 4 is equals to 3. Now, we now have 3x equals to 3. And then x is equals to, we divide both sides by the quotient of s, which is 3. This 3 will divide this 3. This 3 will divide this other 3 here. And then 3 over 3 is equals to 1. Now we substitute 1 for s in equation 1, in equation 2. We choose equation 2. You can choose any equation since you're using elimination method. We eliminated y here. All right. So we now have this equation 2 here. We have 1 plus, sorry, s plus 3y equals minus 4. Then s is now y, 1, okay? S is 1. And then plus 3y equals to minus 4. 3y equals to minus 4, 1 cross becomes minus 1, okay? 3y equals to minus 1, minus 4 minus 1 is equals to minus 5. Okay, y is now equals to minus 5 over 3, okay? Now, therefore, s is equals to 1 and y is equals to minus 5 over 3, okay? All right. Now, the fourth question is solve y raised to the power 3a minus 2, and then base y raised to the power 3 minus b equals to y raised to the power 3, y raised to the power 2a. And y Thank you. This was not clear. All right. Solve y raised to the power 3a minus 2y 3 raised to minus 2, and then y raised to the power 3 minus b equals to y raised to the power 3y raised to the power 2a, and y raised to the power a, y raised to the power b equals to y raised to the power 2. All right, this is the first equation. We consider the first equation. So in the first equation, what we have here is y raised to the power 3a minus 2 and y raised to the power 3 minus b equals to y raised to the power 3, y raised to the power 2a. Okay, now like the first one we treated, this is gonna have the same thing with invisible. There's invisible times before this y here. There's also another invisible times before this y. So I put the times there. Now that implies that we will apply the multiplication law on this, on both these ones, and also multiplication law on these two. So we now take one of the bases from here, and then we have 3a minus 2. Because of times, we now put plus, and then 3 minus b equals to y raised to the power 3. Instead of times, we now have plus 2y. Okay, I'm taking one of the bases. So we now have, since the bases are the same at this point, we can now cancel out the bases and equate the power. So we now have 3a minus 2 plus 3 minus b equals to just like this. And then after this point, we now collect our terms. 3a minus 2b minus 2a minus b equals to 3 plus 3 plus 2 minus 3. Okay, 3 plus 2 minus 3. All right, so what we have next is a minus b equal to a minus 2 equals to we have 3a minus 2 plus 3 minus b equals to 3 plus 2a. Okay, collect times we have 3a minus 2a. Now a has finished. The other variable is minus is b, which is minus b here, and then we now have equals to 3 plus these two cross over, which is these two a's. This one crossing over becomes minus 2. Okay, now 3 is already here. Minus 2 crossing becomes plus 2. Plus 3 crossing becomes minus 3. Now we now have 3a minus a is equals to a minus b equals to 3 plus 2 minus 3, which is equals to 2. Of course, 3 will cancel minus 3, which is 2. Then we have this to be equation 1. Now, considering the second equation, we have ya, yb, y raised to the power a, y raised to the power b equals to y raised to the power 2. I put the times here, okay? Of course, there's invisible times here. So now we take one of the bases and then add up the powers, which is a plus b, okay? Because of times we add, okay, y raised to the power 2. Now, at this point, I will cancel the bases and then equate the power, which is a plus b equals to 2. This is equation 2, okay? This is very simple. All right, now I solve equation 1 and 2. Do I subtract or add? What will determine whether to subtract or add is what I want to eliminate. Now, in this case, I think I eliminated b. So for me since I eliminated b, let me check the b. The b first here is having minus, second b here is having plus. So since the signs are different, I have to add, okay? Now I now have a minus b equals to 2. That's the first equation. A plus b equals to 2. Second equation. So here we have a plus a is equal to 2a. This one is cancelled. 2 plus 2 is equals to 4. Okay. So we now have a equals to, I have to make a separate formula, which is 4 over 2. These two will divide. Okay. Here we'll have 2 into 4 is equals to 2. 2 here is equals to 1. Here I now have a is equals to 2. That's 2 over 1 is equals to 2. Okay. Now, substituting 2 for a in equation 1, this is equation 1. I choose equation 1. I can choose equation 2 as well. This is a minus b equals to 2 from equation 1. Okay. Now, instead of a, I now have 2 because I'm substituting 2 for a. Okay. Minus b equals to 2. Minus b is equal to 2. 2 crossing becomes minus 2. And then minus b equals to 2 minus 2 is equal to 0. Now, b is equals to, of course, dividing everything here by minus. To remove this minus, I have minus times 0 is still 0. Minus times minus is equal to plus. Therefore, a is equal to 2, b is equals to 0.